Welcome to the Math Record. Today I'll be covering area. In earlier videos, I've been focusing more on the process of integration rather than the idea of area. In this video, I want to focus more on the area instead. So generally, there are three types of area. It's going to be in respect to the x-axis, or in respect to the y-axis, or it's between two graphs. So the first one I'm going to focus on is in respect to the x-axis. X-axis. So this one is actually the integration that we've been doing the entire time. So for example, let's say we want to find the area of the curve f of x is equal to square root of x, which is the same thing as x to the power 1/2. And we want to find the area from x equals 1 to x equals 4. So let's draw a picture to see how this looks. So square root x looks something like this, and x equals 1, x equals 4. That means we're looking for this area. Okay. As we said, the area is just the integral, so it's 1 to 4. And we plug in our square x. I'm just going to write x to the power 1/2 because I like to work with powers rather than radicals. Now when we integrate this, this is x to the power 3 over 2. The derivative of this is 3 over 2 x to the power 1/2. We don't want 3 over 2. We want just a coefficient of 1. So we need to scale this down by 2/3. Now we take that integral from 1 to 4. Okay, now when we plug in 4, 4 is the same thing as 2 to the power 2. So this 2 cancels out with this 2, so 2 to the power 3 is 8. So 8 times 2/3 is 16 over 3. Minus plug in 1. 1 to the power 3 over 2 is 1 times 2/3 is 2/3. So 16 over 3 minus 2 over 3 is 14 over 3. So our area for our curve is 14 over 3. So that was what we have been doing the entire time. Now let's try in respect to the y-axis. So this is the same thing as in respect to the x-axis, but now we're going to rewrite our equation in terms of y. And we're going to take the area in respect to y, the integral in respect to y. So let's say we're given our equation y equals f of x equals x cubed. That's what f of x is just y. Actually, let's go and exponential, 3 to the power of x. And let's say we want to find the area from x equals 0. The area from x equals 0 to x is equal to 1. Okay, let's draw a graph. So it's exponential, so something like this. And x equals 0 is right here. X equals 1 is right here. So since we're taking respect to the y-axis, we're not taking this area. We're taking this area. So we're taking area like this. Instead of when we're taking area in respect to x, we're taking area like this. Okay, so we have this area. Now the first thing we have to do is write it in respect to y. This is still in respect to x. So y equals 3 to the power x. Take log 3 in both sides. Log x times let's actually just show the process. Log 3 at 3 to the power x. It's a log, so we can move the exponent down. So x times log 3 of 3. So log 3 of 3 is 1. So it's just equal to x. So that means our equation in respect to y is just log 3 of y. So we have to take the integral of log 3 of y. But remember, we're working with y's now, not x's. We're given x coordinates, so we need to convert these to y's. So when we plug in x equals 0 in here, our y comes out as 3 to the power 0 is 1. Our y value for this, plug in x equals 1, that's 3. So that means our integral goes from 1 to 3. And we're doing it in respect to y now. Okay, so what is the integral of log 3 of x, log 3 of y? Well, that's a little difficult, so let's use our integration by parts, which I'm going to just use my tabular method. So our derivative, easier to do, would just be log 3 of y. And it might not show it, but we can multiply this by 1. So that means we could take the integral of 1. And our sign is positive in the beginning. Now the derivative of this, of a log, is 1 over natural log of 3 times your variable, which is y. The integral of this is a constant, is a linear, so that's just y. And then negative. Well, that seems pretty simple to take the integral of. Y times this y cancel each other out. So using the tabular method, our integral is y times log 3 of y, and then minus integral, because it's a minus sign, so we minus integral of 1 over ln natural log of y times y times a y. So these y's cancel out. It's just 1 over natural log of 3 in respect to y. So when we integrate this, it's log y times log 3 of y minus 1 over natural log of 3 times y. So this is our integral. So we just need to plug in our values 1 and 3. Now if we plug in 3, that's 3 times log 3 of 3 minus 1 natural log of 3 times 3. When we plug in 1, that is 1 times log 3 of 1 minus 1 natural log of 3 times 1. Log 3 of 3 is 1. Log 3 of 1 is 0. So that means to cancel this thing out. So 3 times 1 is 3, minus 3 times natural log of 3, which is 3 over natural log of 3. And 1 times natural log of 3 is this natural log of 3, but it's negative. So this is negative 1 over natural log of 3. Now we're subtracting these two, so minus a negative, we're adding it. That means our integral is 3. Sorry, this is a bit messy. 3 minus 2 divided by the natural log of 3. And this is our area in respect to y. Okay. Now let's find an area between two graphs. This is pretty simple because the area of one graph is f of x, the area of another graph is g of x. And if we want to take the area between two graphs, it's just the integral of f of x minus g of x. And it's just that simple. Okay. Now let's find, so between two graphs. So let's say we want to find the area between f of x is equal to x cubed and g of x is equal to square root x. Okay, so let's draw how this looks. Make this a little bit bigger. So x cubed looks something like this. Our square root x looks something like this. Okay, that means our intersection is right here and right here. And our area is right here. So let's first find out what is our intersection. So x cubed is equal to square root x. So square root both sides, that's x to the power 6. That's x. Subtract x to the other side, so x to the power 6 minus x, that's equal to 0. Factor out our x to the power 5 minus 1 equals 0. So that means x is either 0 or x is equal to 1. Now let's find our y values for these. So when we plug in 0 in any of these two, we should come out with y equals 0. And if we plug in x into any of these two, we get y equals 1. So that means our point of intersections are 0, 0, and 1, 1. Okay, now let's delete this because I'm going to find the area in two ways as we did before, in respect to x or in respect to y. Both ways will give you the answer. It doesn't matter which way you do. But later on in the future, when you're trying to find area between two graphs that are kind of complicated, you'll want to choose the easier one to do. But I'm going to show both ways. Okay, so in respect to x, you always have to think about boundaries. So it will be the top minus the bottom. So the top one is this one, and the bottom is this one. So what's the top one? It's the square root, which we could write as x to the power 1/2, because that's what I like to work with. So we're taking the integral of x to the power 1/2 minus the bottom one, which is x to the power of 3. And we're doing in respect to x, so we're using the x-coordinates, which is 0 and 1. So 0 to 1. So this 0 and 1. Now taking the integral of this, that's x to the power 3 over 2. The derivative of this is 3 over 2 x to the power 1/2. We don't want 3 over 2. We want just 1, so this is 2/3. The integral of this is x to the power 4. The derivative of x to the power of 3, 4x to the power 3. We don't want 4, we want 1, so we scale this down by 1/4. And there's a subtraction sign. And we evaluate this integral from 0 to 1. Now we plug in 1 to the power exponent, 1 to the power exponent, which is be just 1. So this is just 2/3 minus 1/4. Now we plug in 0 in here. 0 to anything is just 0 times something else times anything is just 0. So this is just minus, there's 0 here and 0 here when we plug in 0. So overall, it's just 2/3 minus 1/4. So this would be 8 minus 3, which is 5 over 12. Okay, now let's try it in respect to the y-axis. So remember, we gotta write this equation in respect to y. So in respect to y, let's just set it equal to y. So that means for this equation, we have the x is equal to the cube root of y, or you could write that as y to the power of 1/3. For this one, we take square both sides, so x is equal to y squared. So when we're dealing with y's, we have to think about the boundaries again. So it's got to be the right one minus the left one. The right one is here, the left one's here. And the way you can find it is just draw a horizontal line. So where's the right one? Right here, because that's where it stops. And the left one is right here. So the right one is when we're working with our x cubed, our x cubed turned into this. So that means we have to write that one. So y equals y to the power 1/3. And our x to square x turned into this one. So that's our left equation, so minus y squared. And then we take it in respect to y, and our coordinates go from y equals 1 to y is equal to 0 to y is equal to 1, as shown right here, because that's our intersection. Now let's take the integral. The integral of this at 1, that's 4 over 3. The derivative of this is 4 over 3, y to the power 1 over 3. We don't want 4 over 3, we want 1, so we scale by 3/4 minus y to the power 3. The derivative of this is 3y squared. We don't want 3, we want 1, so we scale by 1/3. Now we evaluate it from 0 to 1. Plug in 1 in here. So 1 to the power, 1 to a power, they basically just have 1. So that means 3 times 1 is 3/4. 1/3 minus 1 is 1/3. Now we plug in 0, as we did before for this example. We know that it's just going to be 0. 0 times a number 0 minus a number times 0 is 0, so overall it's just 0. So 3/4 minus 1/3. 3 times 3 is 9. 1 times 4 is 4. So 9 minus 4 is 5. And 4 times 3 is 12. So simplifying it, you see that in both ways, the answer should come out the same. And it should, because no matter which way you do it, the area is just the area. But it just depends on which way you want to do it to make it easier. Well, thanks for watching, and in the next video, I'll cover volume from revolutions.